Chapter 17, Part 1, Monitoring and Record Keeping for Central Service. Learning objectives. As a result of successfully completing this chapter, readers will be able to 1. Discuss the importance of monitoring work areas and process within the Central Service Department. 2. Discuss the importance of record keeping. 3. Explain the types of monitoring needed in each area of the Central Service Department. 4. Explain the need for monitoring and review of the sterilization process indicators that help assure quality control, such as need for monitoring, chemical indicators, sterilization load control information, physical and mechanical monitors, biological indicators, Bowie-Dick tests, and then 5, discuss the importance of employee training and continuing education records. Introduction. A great deal of planning and effort goes into every aspect of the Central Service Department. For decontamination area to storage area, rigid requirements must be met to help ensure the safety of patients and healthcare workers. Documentation is required to provide a record that those requirements were met. And if requirements were not adequately met, documentation provides a record to assist with performance improvement. CS technicians are involved in the record-keeping process across many different functions of their jobs. Records provide the evidence that the process were routinely checked, and information collected provides a quality framework that will be examined by surveying agents such as the Joint Commission, Centers for Medicine and Medicaid Services, and state agencies. If the healthcare facility is involved in a legal claim regarding any product that were dispensed from or processed through CS, records can help demonstrate that a specific standard of practice was followed. This chapter provides information about record-keeping requirements for CS and addresses methods used to monitor and document conditions and process to meet established requirements. Special emphasis will be placed on the methods used to monitor sterilization process and the record-keeping required for those processed. The importance of accurate records. Records are kept to document many processing conditions in the CS department, including sterilization cycles, preventative maintenance, and routine equipment testing and cleaning. It is important to note, however, that records are only as good as the information they contain. Having incomplete records is essentially the same as having no records at all. The following are some facts about CS department records. Record keeping is mandatory. CS department record keeping is not optional. It is as much as a part of the job as assembling instruments or operating sterilizers. Records must be accurate. Information must be documented as it is, even if the information indicates a process has failed to meet the expected standards. Records must be legible and understandable. Handwritten records should be legible to anyone who needs to review them. Slang, unapproved abbreviations, and nicknames should not be used, as the terminology may confuse the reader. Records must be complete. All information should be documented according to the department's specific requirements. Records should be audited routinely. Routine audits ensure that documents contain all necessary information. Accurate and complete records provide documentation that the CS department is following standards, regulations, and its own procedure to help ensure continual adherence to best practices. Definition: monitor. Monitor is to watch, observe, listen, or check something for a special purpose over a period of time. General monitoring. CS technicians should continually monitor their environment to help ensure that the integrity of each work area and the process performed in those areas are maintained. Some monitoring is informal, such as watching to ensure that everyone who enters the area is dressed appropriately, practices good hand hygiene, and follows established traffic control guidelines. This type of informal monitoring is not recorded, but each employee is expected to identify and correct breaches in established protocols. Visual monitoring is especially important when monitoring dress codes in the decontamination area. Visitors such as loaner instrument vendor personnel or facility employees from other departments, for example, maintenance, biomedical engineering, or environmental services, may not be familiar with or understand the importance of personal protective equipment, PPE, and may endanger themselves if they enter the area without proper attire. Formal monitoring of the physical environment is also required. For example, room temperature and humidity must be monitored at least daily to ensure they meet the established standard. That data must be recorded. Some departments use electronic devices to collect the data and transfer it to an electronic record, while others collect the data manually. In either case, CS technicians must have the data recorded and accessible. Figures 17.1 and 17.2 illustrate examples of manual and computerized data collection methods used to monitor temperature and humidity. CS technicians also monitor their work areas for safety hazards. They learn to keep a watchful eye for unsafe conditions, broken or unsafe equipment, and other issues that may put themselves or others at risk. Once identified, they remedy the situation if possible, wiping up a spill, for example, or report it to the appropriate person to initiate a repair or replacement process. Departmental cleanliness is also monitored by CS technicians. While routine cleaning is performed by the Environmental Services Department, there are areas in the CS department that staff are required to maintain. For example, CS technicians are responsible for keeping their work area clean. This not only means cleaning their work areas as designated at designated times, for example at the end of the shift, but also means cleaning the area whenever it becomes contaminated or soiled. CS technicians are often assigned specific cleaning duties within the CS department. For example, they often are responsible for cleaning cabinets, racks, and carts in the sterile storage area. CS staff are assigned to clean those areas because of their understanding of the sterile package handling and their ability to handle sterile items, clean storage cells, and return those items to the proper location without compromising the integrity of the sterile packs. The cleaning process in this very important area must be documented to provide a record of routine cleaning. CS technicians are also responsible for cleaning the transport equipment in their area. Every effort must be made to limit the presence of dust, lint, and microbial contamination in the work area. Microbial contamination must be kept to a minimum in all work areas. Excess dust in the work area can easily be transported to items being prepared or for sterilization or onto sterile packages. In either case, that dust may then become airborne and be introduced into an open wound or during procedure. Figure 17.3 provides an example of a sterilizer loading cart that has not been recently cleaned. The dust and the lint pose a significant threat to patient safety. CS staff also monitors equipment within their work areas. Some of that monitoring is informal, such as checking the temperature of the heat sealer. Other monitoring is formal. All small electrical equipment has a current preventative maintenance sticker, PM sticker. Items falling outside of their PMD should be rechecked according to the facility's policy. In addition to general guidelines for all work areas, there are unique requirements for each specific work area. The following sections review those requirements. Decontamination area monitoring. Monitoring of the decontamination area is important to ensure all cleaning equipment is properly working. If the equipment is not working properly, instruments will not be clean and safe to handle. Water quality. Poor water quality will impact every process in the decontamination area. Cleaning chemicals must be used with the recommended water pH and will not function as designed if the water's pH is incompatible with the chemical. Hard water will cause scale to form on equipment, reducing the equipment's cleaning effectiveness. Water quality should be monitored to ensure that the appropriate dilution of the chemicals utilized is correct. Commercially prepared water testing products may be purchased to test water on a weekly or daily basis. Mechanical cleaning equipment. Specific tests are available for each type of equipment. CS technicians must follow the equipment manufacturer's instructions for use for inspection and testing. If the machine does not meet the inspection requirements outlined by the manufacturer, or if the test fails, the CS manager should be notified immediately. All test results should be documented. Ultrasonic cleaners. Ultrasonic cleaners use a process called cavitation to remove soil from instruments. Commercially prepared tests are available to test the efficacy of the ultrasonic. Irrigating ultrasonic cleaners. Irrigating ultrasonic cleaners are used to help clean lumen instruments. These units also use a cavitation process, but they employ irrigating tubes that flush solution through each lumen. In addition to the cavitation test, the irrigating tubes should be checked to ensure water is flowing freely through the tubes. Test results should be documented. Washer disinfectors. Washer disinfectors should be visually checked at least daily to ensure screens are clean and that rotating arms are properly attached, rotating and unclogging. Washer disinfectors should be tested for proper cleaning ability. Commercially prepared products are available to assist with testing process. At the end of each cycle, physical monitors should be checked. On a washer, the physical monitor is the cycle printout or data log. The printout should be verified by the operator to ensure that the thermal disinfection temperature set by the manufacturer was attained and that all other cycle parameters were met. Cart washers. Cart washers must be monitored to ensure that they are working properly. Floor screens should be checked at least daily to ensure they are free of debris. Check rotating arms or cables to make certain they are operating as intended by the manufacturer. Cart washers must also be treated to ensure they're cleaning effectively. This can be done using a commercially prepared test. High-level disinfection monitoring. Many items processed today, such as flexible endoscopes, some respiratory therapy equipment, and other heat-sensitive Class 2 and semi-critical items are high-level disinfected. The disinfection process contains many variables that can render it ineffective. Therefore, it is important to carefully monitor the process. Surveying agencies review disinfection records as carefully as they review sterilization records. Chemical disinfection monitoring. Test strips are used to ensure the minimum effective concentration. Minimum effective concentration is MEC. They are used to ensure the minimum effective concentration of the disinfectant solution. See Figure 17.4 as an example. When a new bottle of test strips is opened, test the efficacy of the strips according to the manufacturer's instructions for use. Document the date of the test strips when they are opened and the final date the strips may be used per the manufacturer's instructions for use. Document test results per facility policy. Now, manual disinfection. Documentation of manual disinfection process should include the following: date, test strip results for minimum effective quality and control, expiration date of test strips and disinfecting solution, and items disinfected. Note, some procedures also require that the solution temperature be recorded. If the disinfected item is a flexible or rigid endoscope, the following must also be documented in addition to the above: name of the technician who cleaned the scope, and name of the patient of whom the scope was used, such as with the patient ID information if available. Automated endoscope reprocessor monitoring. As the name implies, an automated endoscope reprocessor, AER, is used to disinfect endoscopes using an automated process. While this process is less labor intensive than the manual method, monitoring is still just as important. As with manual disinfection, the disinfecting solution in the AER must be tested for each cycle. The test strips and testing procedure remain the same as with a manual system. The AER, manufacturer's instructions for use, must be followed to ensure proper testing of the disinfecting solution. Most type of AERs have a physical printout of the cycle available after the cycle is complete. This printout should be reviewed to ensure all set parameters were properly met. Technicians should then sign the printout to show the cycle has been reviewed. Some AERs have a computerized control panel that allows the input of items sterilized in each cycle. If this feature is not available, then the items must be manually documented. With the exception of the printout, documentation for AER disinfection is the same as with the manual system. Sterilization area. The sterilization process requires a monitoring system to help ensure that the sterilization parameters are being met. Because it is difficult to prove an item's sterility without contaminating it through handling, conditions that can indicate that the parameters for sterilization have been met must be monitored. These sterilization monitoring protocols are an important part of the CS department's monitoring and quality assurance systems. Several control measures must be used to ensure the conditions within the sterilizers are adequate to achieve sterilization. Process indicators. Sterilization process indicators help to confirm that packages have been properly exposed to the sterilization process. ANSI and AMI ST79 2013, the Comprehensive Guide to Steam Sterilization and Sterility Assurance in Healthcare Facilities, states, chemical indicators are designed to respond with a chemical or physical change to one or more of physical conditions within the sterilizer chamber. There are two basic types of process indicators: internal chemical indicators, CIs, that are placed inside a package to be sterilized, and external CIs that are placed on the outside of the package. CIs provide a visual indication to help identify possible sterilization failures. They can detect problems with incorrect packaging, loading, or other procedures that can also detect certain equipment malfunctions, such as air leaks, wet steam, and inadequate temperature. CIs are an integral part of the sterilization monitoring program and are used in conjunction with physical monitors and biological indicators to demonstrate the efficacy of the sterilization process. After sterilization process, indicators are examined by the CS technician to ensure complete exposure. If process such as packaging and loading have been done correctly, the CI will have changed color. By contrast, an incomplete color change may provide the first sign that part or all of the load was not properly sterilized. While chemical indicators do not verify sterility, they are an important part of the larger sterilization monitoring system. External chemical indicators. External chemical indicators often are the first performance test the user sees upon removing a package from the sterilizer. They provide instant results and visual evidence that the package was exposed to sterilant. Note, external CIs do not indicate that the item is sterile. External process indicators include tape, load cards, or labels on the outside of the packages and are also examined before the items are dispensed or opened to ensure the proper processing has occurred. See Figure 17.5 for an example. Internal chemical indicators. Internal CIs are placed inside the package and provide evidence that the sterilant penetrated the package. Note, internal CIs do not prove sterility. See Figure 17.6, which provides examples of some CIs. CIs should be placed in an area of the package tray or container considered to be the least accessible or sterilant penetration. Note, the location is not necessarily at the center of the package, tray, or container. If the interpretation of the CI in a package, tray, or container suggests inadequate sterilant penetration, the contents cannot be used and should be returned to the CS department for investigation. Note: it is possible to have one or more unacceptable indicators in a load because of improper packaging or loading, with the remainder of the load acceptable. CIs showing a failing result should require further investigation to determine the cause. The following could cause a CI test failure: utility or sterilizer malfunction, inappropriate sterilizer load techniques, not using the correct CI monitor, wrong cycle selected, poor storage of the CI indicator, improper packaging techniques, not following the container's instructions for use, and not following the medical device manufacturer's instructions for use. Some facilities use CIs that consist of heat-sensitive dye applied to a cardboard strip or a dye that moves along a window. When exposed to a sterilant, these devices gradually change color, thereby integrating a time component to the measurement. Physical monitoring. Physical monitors include time, temperature, and pressure recorders, displays, digital printouts, and gauges. See Figure 17.7. During and at the end of the cycle, and before items are removed from the sterilizer, the operator should review the monitor to ensure all cycle parameters were met. Upon completion of the cycle, the operator must sign the chart as proof that it was monitored and that all sterilization parameters were met. Physical monitors are needed to detect equipment malfunction as soon as possible, so appropriate corrective actions can be taken. See Figure 17.8. If there is any indication of malfunction, the department manager or designee must be notified immediately. The load should be considered unsterile and the sterilizer should be removed from service. It should not be reused until the problem is corrected. End of Chapter 17, Part 1.